Hey guys, it's Scott at Modeler X. How's it going? It seems like it's been forever since I've done a video. I'm sorry about that. I wanted to do a quick video because I'm kind of going into uncharted territory. I'm building a 350 Enterprise TOS, and the request came in to light the little ball at the back of the nacelle, which I've come to learn is called a Space Matrix Restoration Coil. That one. Sorry, wrong finger. But, oops, drop that. It's basically that piece right there. And so in terms of lighting it, it's a challenge with through-hole LEDs, which tend to focus the light through the clear lens, and tape, LED tape, it's too small of a space to do that. So I started looking online and began looking at some of these. They're called high-power LEDs. And they're an interesting shape. They're about an inch square, a little bit less on this side, a little bit more on that side. But they're the same LEDs. Like I've got one of these little powerful flashlight things, one of these, and it's looks like the same exact material. So they're extremely bright, and in terms of ordering them, they're about $1 a piece, and you can get them in all the colors. There's several shades of blue, there's several shades of red, and there's ultraviolet, there's cool white, normal white, warm white. So you can get them in all sorts of colors. In terms of working with them in a modeling capacity, these are way overpowered, which is, let me get into some of the properties here, but these are built with the specs that they should run at 9 to 11 volts, which if you run them at that, they are so bright you can't even look at them. It'll leave spots in your eyes, like you probably shouldn't look at that, like you shouldn't look at an eclipse. But the nice thing is you can ramp the voltage off and get down to a real acceptable level where you, with voltage, can control how bright they are. And each element of this has sort of little sort of a 3x3 grid that emits light. And in fact, this one right here is an RGB model, and it has 3 of those little, of the 3x3, 3 are red, 3 are green, 3 are blue. And then this is, I got a blue variety, which, doesn't have the yellowish on it, but it's way blue. And then this is a cool white, which I thought would be a good color, although I ordered a number of them to try in the back of our Space Matrix Restoration Coil to see which would look best. And I'll get into the implementation of that in just a second here, but I want to talk about the properties that I've sort of discovered in playing with these. They have the emitting surface on the top, and then there's, as you can see, I've wired this one up, and it's got a red lead and a black lead coming out of, obviously, the positive and negative. Same for this one, and then the RGB positive is here, and then you connect the ground to there's 3 different leads down there. But kind of putting those two aside, the connectors, you're gonna have to solder them, and it looks like there's some room to trim if this is not big enough for your space. But I was kind of looking for, let's find a panel that can emit light that is not targeted like a through hole, that can kind of just give me what do you want to call it? Just kind of a panel behind, this to light it up. So as I said, it's 9 to 11 volts, but I'm playing in the voltage range of 7.4 to 7.6, and I do have a power supply where I can adjust the voltage and, find exactly where I want it to be. So I'm going to get into that as it relates to running this on a Starship that's at a constant 12 volts, and it just involves resistors. and playing around with that. But one other thing I wanted to mention about the properties is when you're running this at 12 to 11 volts, which, like I said, makes this so bright that you can't even look at it. One of the other things that happens is this unit becomes really hot, like almost too hot to touch. So I'm thinking it's way over 100 degrees, and you shouldn't expect to be able to use this inside a model if you're going to do something that bright. But then again, I don't know, I can't think of an application where you'd want to have something so bright that you can't even look at going on inside of a model. So if the whole purpose of the video here is just to kind of share stepping that down to where we can maybe get a inch by inch shine, which, you know, you can pull back or pull forward to light up something from the behind. And when it's running at that level, there's no heat problem. So those are some of the properties. Let me reset this, and we will show you how I'm implementing that into the 350 TOS Enterprise. So to get this accomplished, the whole point was to backlight this piece right here. And one of the things that really aggravated me is the plastic is colored, and every time I shot, even if I thin this out, it's not going to be the color I want it, which I want it to be cool white, like the LED, and kind of like the back when you watch an old non-restored Star Trek episode and the Enterprise is going around the planet, those space matrix restoration coils are white. So that puts in my mind we need a clear part, and I thought of casting them, but I didn't. And somehow I came across a company called US Plastics, and they actually make a half sphere, 1 inch, I'm showing it here, piece. And I ordered 5 of these, and I don't know, it wasn't too expensive. I want to say it was like $10 or so. But if you look at them, let's put these out, they're about the same size, and turning them that way, and they look like that. So we got that, and then of course, oh shoot, I dropped it. There it is. Okay, so I sanded one down, and there we are with that. And then the other trick is, you know, you look at the side of this piece and it's curved, and unfortunately, you know, this is supposed to mount, so the hole is not big enough. The hole is way smaller than 1 inch because this lip fits in there. So you can't, you know, I'm thinking lay this on the top like that. But then you gotta, because this surface is curved, we're gonna have to start taking material off on the top and the bottom there, which isn't too big of a deal. And I've done that. So sort of shaping the materials is kind of over in this quadrant, but then we get back to the lighting. And so this piece, I'm thinking we can, and here's sort of a mock-up. I've laid this down inside of the cavity here, and I haven't glued it yet. That's why everything's moving around. But I do have a signal marker to flash the navigation lights on the back of the nacelle, which is why I had to create a plastic piece like this to go slip inside here, and then the LED is sitting right on top of that surface, and that's kind of what you're looking at here. So, and then let me try to illustrate here. This will go on top of that and be lit from behind, and we dial down the voltage so that it's subtle. It's bright enough to light it up, but keeps its place in the universe, so to speak. That's what's going to happen here. and you can see that all working out there. So that's kind of the idea. And the one, oops, I see it already fell out, but here's that. And then I just, basically there's a LED in there to flash with the nav lights, and I just created this piece, and here's the corresponding piece for the other. Just slipped it right in there, and then this high power LED just kind of goes in right there. And then after we get the sanded space matrix restoration coil the way we want it, and kind of what I did is I just sanded off one edge there and one edge there, and kind of just eyeballed it to fit it to where it's going to go. That's what we're shooting for. So let me take a break and see if I can't get this lit up and see, well, the camera's going to wash it out, of course, but let me see if I can't get a demonstration going here. All right, so let's go for implementation here. I have the end of the nacelle sort of mocked up with a little black piece holding up the high power LED, and power leads are connected. My voltage right now is 12 volts, so we're going to be introducing a resistor to pull this down to the voltage that we want. And the way I sort of tested this out is many years ago I bought a whole assortment of resistors from, I think it was Radio Shack, which I don't even think they're around anymore, but it had a gazillion resistors of all flavors, and I sort of tucked them into my storage area, and some were more pervasive, like the 1K model. They gave me 50 of them, but these, you know, they gave me 6 of them. But I kind of just started playing around with it. It's like, I know it needs to be more than 470, which is what I would normally put as a resistor for an LED. And so 470 I put on there, and it was still too bright. So you just start getting the resistor higher and higher, so it restricts more energy. And you get to a point where I'm in the thousands. So I was playing around. This one, for example, is 4.76K. And this one is 3.3K, and this one was 2.2K, and it actually happened to be the whole, you know, right in the middle. So here's my 12 volts, and then the connection to the LED. So when I test them, I just sort of connect that there, and connect this one here. If I can grab it, come on. And as you can see, the LED lit. And camera technology, it always appears way brighter on the screen than it does to me. But this is about where I eyeballed this, and that's where I want this lighting to be. So now if we grab the sanded down sort of light diffusing version of this one, and I put it over, oops, shoot. All right, we'll stick that back in there. And we put this back in here. Now what I'm trying to achieve is that. And I know that's probably washing out. Let me try to reduce the voltage here so it looks like what I'm actually seeing. That's about what I'm seeing in real life compared to the overly washed out look, which, You know, maybe it could even be a little bit lower. But the nice thing here, it just increase the resistor size, and you can reduce this or increase it to whatever you want. And then we're just going to glue this piece to the outside surface of, you know, the back end of the nacelle, and then use this piece and insert it like that, and put the LED, you know, this guy on top of it, and button it down, and we're good. So that's my thinking. Comment if you want. If you have questions, please let me know. And my email is scott@modelerx.com. And thanks so much for watching.